Hello, everyone. Welcome to episode 45 of the Day Zero podcast, non-live edition. I'm Spectre. With me is Z. As our live regulars know, this episode couldn't go live this week. We will be back to live episodes again next week, though, so don't fret on that point. In this episode, we have some PDF exploits, GPGme, and Favicon tracking. Before we start, I'll quickly mention last week we did a discussion video on the future of exploitation. That's up on our Day Zero YouTube channel. So check that out if it sounds interesting to you. I imagine it probably will to most of our regular viewers. But yeah, with that out of the way, let's jump into it. So we'll start with one of the bigger topics this week that I saw circulating on Reddit and stuff like that. It was the Brave browser leaking onion addresses and DNS traffic. So this post was made on the Ramble, which it seems to be like a knockoff of Reddit. Basically, it was basically a post that somebody discovered that Brave, with its Tor mode integration, was leaking onion addresses and DNS traffic through the ad blocking functionality, and that's because the CNAME based ad blocking would send out those DNS queries. So yeah, the technical details aren't super interesting. It would just send those DNS queries to public DNS resolvers instead of Tor nodes, which is obviously quite a big concern when you're talking about why you'd want to use Tor in the first place, especially if you're like a potential target, like a journalist reporting on your government or something. Although in that case, you probably shouldn't be using Brave's Tor mode. You should probably be using an actual Tor browser.
Yeah, I
Um,
mean, the Tor browser is definitely a lot more recommended than Brave's Tor mode, but Brave's Tor mode is there, and I don't think you'd have any expectation for them to be significantly violating your privacy in this way.
For sure. Yeah,
It
and I
does,
actually have a point on that a bit later.
yeah. So it does seem like at least Brave already had this fixed actually before it was before this user ended up reporting it. I believe there was a ticket a couple months ago about it. I might be wrong in dates; might have just been a couple weeks. But it does seem like it's already been fixed, or at least it's fixed in nightly right now. And that actually, I believe it went into nightly before this report was even made. So, hopefully, if you're updating frequently, you should get the update for this pretty quickly.
Yeah, so from what I saw, it was reported on the Brave Hacker 1. I did go looking, and it doesn't look like that report is disclosed. Um, but yeah, there's some interesting drama around the issue. Like you said, it has been fixed. It was pulled up. It was lifted to stable due to the public disclosure of the bug. At first, though, the reports were disputed. There was some confusion around if this issue was actually a real issue, and then several people did independently verify in that thread that where it was posted that this is actually an issue. And eventually, Brave came out and said, "Yeah, we're going to pull that up to stable. It was already reported." Um, but that was only after it got some mainstream coverage. So
So, is that something besides just our privacy? Basically blocking the report on their subreddit. So all I
I
understood
think that
was
was
that
the main
our
catalyst of it.
Yeah, because all I
Um,
saw was our privacy basically said, you're not a, recognized security researcher. We don't want to dive into conspiracy theories. Therefore, get this recognized by better resources.
Yeah, there was a lot of mudslinging in the subreddit. A lot of people saying that the mods were brave shills and they were suppressing the information. There was a lot of funny comments, but I think that was the main motivation behind the reports being disputed was the privacy subreddit. That's where I saw a lot of it anyway.
Yeah, and I can
Um,
kind of understand where like our privacy is coming from if they don't want to get a lot of those conspiracy theorists and that sort of thing. Like just having a higher expectation for who just reports something rather than just allowing an individual to do their own kind of, yeah, I totally found this, and kind of allowing that to create drama. I don't know, did our privacy actually allow this to be posted once it gathered some traction and other people had verified it?
I think eventually it did make it there, yeah. And the mods had made a statement, I think, on that subreddit as well, saying, we can't independently verify all these claims, or like it's a bit of a slippery slope because if there's hundreds of them reported, we can't be reasonably expected to verify them all. So yeah, I mean, I kind of agree. I think people were a little bit harsh on the moderators of the subreddit, but I mean, yeah, it was just kind of an unfortunate situation, I guess. I don't know if I'd really blame any particular party.
Well, I
Um,
mean, you can kind of blame Brave for the issue itself.
True.
But beyond
So
that, I mean, I think, the moderate, assuming our privacy maintains that throughout. I'm not active on that subreddit, so I don't know. But assuming that has been their regular policy, I think that's fair. Because, I mean, there definitely are people that will just post, nonsense pretty much and get it up, though, because a lot of people just don't understand in the first place. So, see a nice title and that's enough.
Yeah, blind leading the blind, kind of, in a way. Um, I did want to talk about some of the comments that I did see. There were some people commenting that the convenience over comfort will always screw you type comments, saying if you were hit by this, you're an idiot. You shouldn't be using a non-Tor browser to access Tor. Which, I mean, we kind of did bring up. You probably should be using an actual Tor browser and not the Tor mode in Brave. But I do feel like it's victim blaming a little bit. Um,
I
and
mean,
it's just an
Brave shouldn't have
unfortunate
the
issue.
issue. I mean,
Yeah,
the fault, I think, lands on Brave, not on users who decide to do that. Yes, there are always more steps you can take to be more secure. Um, it feels like I have to agree with you. Like, that does feel a little bit like victim blaming. It's also like you can make that same argument about almost anything. If anybody ever gets compromised, they could have done something more to be more secure.
it reminds me of the situation with the North Korean hacker blogs and people saying, "Oh, if you got hit by this, you're dumb because you should be visiting these blogs in a virtual machine." Like, okay, yeah, maybe you should be, but the convenience aspect makes it so that most people aren't going to do that. And I think it's the same situation here, basically. But yeah, so we'll move on to some of our another issue. Actually, our first paper of this episode covers another privacy-based browser issue, which also affected Brave, but not only Brave, it affected multiple browsers. It's about favicons and how they're cached, specifically how difficult they are to clear and how that can be abused. So the paper talks about this study they did where they found um, most of the favicons in the top 1,000 top 10,000 websites. They were looking at like the expiration of the favicon, and it was between like most of them were 90 to 365 days, I believe. Um, and they were thinking about like how the favicons could be abused to create a persistent a tracking identifier on the browser. And the way they do that is they generate that unique identifier by redirecting the user through a bunch of subdomains. I think what's the term for it? C? Is it called an n-bit attack?
No, it's just you get an n-bit identifier uh based on having like n subdomains. It's like n-bit
Yeah.
is
Okay.
just like n as in a variable, like x bit, but
Yeah, I didn't
n
know
is
if there
more
was a
common.
like better term for it. That's why I was a little bit confused there. But um, yeah, so you go through n subdomains and you get cache entries created for the favicons in that redirect. And then you check for the presence of those later by checking if the favicon is requested by the user. Because if it is, that means it's not cached. And this is non-destructive because they can serve an error on the favicon to make it so the unique identifier doesn't get smashed by caching a favicon that wasn't intended to be cached.
And to be clear, I mean, we kind of just touched on it with the n-bit identifier, but if you had, say, 5 subdomains, then you would be able to create like that 5-bit identifier based on a Spectre talk about here, where you would say cache 2 of them. I believe they use the example, I want to say it's page 5 or page 6. Yeah, they have the example of doing a 4-bit one, where you might have like subdomain A, B, C, and D, and then you'll create cache entries for B and for D, which would kind of create the ID of being 0, 1, 0, 1, where A being 0, B, which you set, is 1, and so on. I thought this was a really kind of interesting tack. And the fact that favicons, this is probably, like, I would guess, due to, like, old legacy code, but they just don't get cleared with your normal cache. Like, you don't just get into your browser and go, hey, I'm going to, clear the cache or clear all this data. It doesn't clear the favicons. So that's what makes this really persistent. There's no easy way for your standard user, besides literally just deleting some of the profile, or files inside of the profile, to actually get rid of the favicons.
Yeah. So I did want to quickly call out there's 2 figures on page 5, which I think illustrate the attack really well. Figure 2 and figure 3. That kind of helps you get your head around what's what's going on and the control flow there. Um, so yeah, I agree. I think it's a really cool attack. The other notable thing is this can be scaled. As they noted, it's not difficult to create subdomain paths for however many targets you want to be able to hit. But it can also affect incognito users because it shares the Favicon cache. Now, obviously, you shouldn't really be relying on incognito as a security shield. It outright tells you that on most browsers when you enter incognito or whatever the term is for it on that browser.
No, but
But some people do use it as such.
You should be able to rely on it as a privacy shield, because that's quite literally the point of incognito. It's not a security shield, but it is a privacy shield, and this violates that.
Yeah. So it's definitely notable that it can cross that threshold into the incognito world. Um, but yeah, from a technical point of view, I think this was a really clever attack. Um, Now, just like the last topic, though, I remember you mentioned to me, Z, that there is a little bit of drama around this. Now, I didn't really go looking into what that was about. So, do you want to clarify what some of the drama was about?
Sure, I will, but before I jump into that, one point I would want to kind of clarify with this attack is more on the practicality of it. You can't, as far as I understand it, you can't really perform this in like an iframe. When you load the page in iframe, it's not going to make that favicon request. So you're redirecting a user through, 4-5 domains, kind of as the top window. That is kind of going to be recognizable. It takes, a couple seconds. That, I think, kind of detracts from the practicality of the attack when you're not able to do this silently and in the background. You're not able to just track them. You've got to waste those few seconds at the front kind of doing all of these steps. That just makes it really obvious, and a lot of people just kind of want to get to the site immediately. That said, if a site were doing it, I could imagine some people not quite noticing and just kind of associating it with some of the load time, but I don't know, a few seconds does feel pretty long for me.
And you do have to make those requests twice, right? Once to write the identifier and another time when you want to read it. So you'd probably need like an XSS or something on a site that the user would use often.
But you need to do this from the top window. You can't you can't hide this. You need to be changing the main URL. You can't just have it you can't just make a cross-site, you can't use cross-site scripting to just make a request to the domain.
No, I mean using cross-site scripting just to redirect the window, the top level window. But yeah,
you're still doing this big redirect over a few seconds. It's very loud.
Yeah. And the other thing is too, it's also going to enter your history if you're browsing on like non-incognito mode. So it is
well,
pretty
a lot of sites
accurate.
break your history anyhow, so that's par for the course.
Yeah. But
yeah, for the drama, I assume that's where you're going to go.
Yeah, I was just going to say, even though the practicality is limited, I think it's a cool attack. I did want to get to the drama though, yeah, so you can continue on that.
Yeah, and I agree on that. I think it's a cool attack. I'm not sure if, I have my doubts as to whether or not any tracking agency will have already been doing this, or that it really will have been adopted because it's so loud. As for the drama, the big issue here, and it's actually kind of headlined right at the top of this document, with the statement from NDSS 2021, the program committee being about their devote to the ethical principles and all that. So what happened with this is it impacts Chrome, Safari, and Edge, and Brave. You'll notice that Firefox isn't mentioned there. Firefox they tested, but in Firefox there's already a bug where the favicons just were never cached. So every time it needed a favicon, it would go and make the request again. So the authors of this paper reported that as a bug, and note in the paper that they believe that once that bug was fixed, Firefox would then be vulnerable, but they didn't mention this vulnerability in their bug report. So there's kind of the ethical considerations around reporting a bug and trying to get that bug fixed and not mentioning the vulnerability that it would then introduce into Firefox.
Almost like trying to plant a bug.
Yes, and I don't want to place any malice on the actual authors. I think part of it really just comes down to the author thinking, here's a bug report, I'm going to give them, the bug details. And, if they are vulnerable, we'll report that later. I do think they should have included that. They do include a bit of an appendix explaining at least their perspective on it. I'd give them the benefit of the doubt on it just being an oversight. I can definitely imagine somebody thinking like, I was doing this research, I found this bug, I report this bug, and kind of just leaving it at the bug and not trying to go into all the speculation and possibly just trying to fan the fire in a sense of, or trying to spread fear and uncertainty and doubt. I could imagine them trying to avoid that, so not necessarily going into, and there's maybe this other exploit, just here's the bug. So I can understand kind of why that oversight might have happened. Again, I do think they should have mentioned, like, there should have been a bit like, we were doing this research in this area and came across or we weren't able to determine if Firefox would be vulnerable because of this bug, and like including it that way. But I can at least kind of understand, but there was this little bit of drama about it.
Yeah, I guess your perspective on that will be influenced on how cynical you are. If you're a really cynical person, I could see how you would think that they reported the bug just so that they could get this exploited on one more browser. And when, like, just thinking, like, when they were trying to look for it, it's like, oh, it doesn't work on this browser because this one really weird quirk. Let's try to get that fixed. Like, to be clear, I don't think that is what happened. I think it is more benign than that. I think it's just that, like you were saying, they probably weren't 100% certain that it would affect them when they fixed the bug, and that's why they didn't mention it. But it probably was worth a footnote. But I mean,
Well,
hindsight is
there's an
2020.
appendix now that indicates their thoughts on it. So like they've clarified the issue, and Firefox didn't, or it was fixed in Firefox. Like, it's not vulnerable. Neither is Chrome or any of the other browsers now. I believe all of them have patched this. They disclosed it yet in July, several months before the conference, which is happening right now.
Is there details on how they fixed that issue? Because I am curious how you would fix something like this, because it is kind of a, like, one of those attacks where it's not like an easy just fix one line and it's done.
I would imagine they just move things into the same cache as the rest of it.
Yeah. Okay. Fair enough.
I guess I should say I don't actually know. I thought I read somewhere, but I don't see it being mentioned here in the paper. Just as I quickly glance at it, that all of them were fixed. It might be mentioned here, and I just can't find it. I do remember reading that, but I don't have a source on it, so you might need to look into that for yourself.
Yeah, it is a bit of a large paper. I got lost a few times just trying to look around for things, so that's totally fair.
Nonetheless, I mean, definitely a cool attack. I like this.
For sure, yeah. So we have the first of two PDF attacks. This one actually being a class of attacks called shadow attacks against digitally signed PDFs. And it relies on the basis that signed PDFs can receive incremental updates, which can be used by attackers to inject and add content or remove content from a PDF without violating the signature. And this is because there's exceptions for allowed changes, which are defined by the PDF viewer in question, which opens up some holes where there could be some adjustments made which don't throw any warning flags or anything.
Yeah, so I do want to kind of pop in and mention that there have been other attacks that have looked at how, or have looked at like PDF parsers and broken some of the, or been able to add changes and modifications because of parser errors. What's interesting about this paper and about the way they've gone about this attack is they're purely going after modifications that most readers would consider harmless. So as Spectre was mentioning, like with a PDF, you kind of have the three main parts. You've got the PDF body, the catalog, and then all the parts under it, acroforms, metadata, pages, all that kind of under there, xref table, and then the trailer. So the xref table just containing references to the actual byte positions of all the objects, and the trailer points out where the xref table is and the identifier to that root PDF object. So those incremental updates, when you add a signature to a PDF document, you're actually adding an incremental update. So in order to be able to sign a document after somebody else has signed it, you still need to be able to make some of these incremental updates or add another one. So that's where you kind of have some of these allowed features. Like I said, the interesting here is the fact that it does focus on these harmless things, and it kind of creates these three different, or class, they refer to as three different sort of attacks with several variants. One of them being the idea of hiding content from a victim behind a visible layer. Basic idea there. I think if you've dealt with like HTML, you might, or with CSS in particular, you might get this. Hiding a form field behind an image is an example of that, where you would create an overlay object. So you'd have like your fired message or whatever you kind of want to hide. Then you create an image that's like, you won, sign this document. I believe that's kind of the examples they tend to go for. Yeah, you're all fired, get out immediately versus sign the document to get a reward. You can do whatever. I mean, it's just there as an example. But you would basically just put things, behind an image, and then you could use an incremental update to change the order of the xrefs, which would result in changing the order of the rendering, which means one's going to be rendered behind or in front of the other. So like two form fields of the same size, one in front of the other, you're only seeing one at a time, but you're not actually changing any content. Therefore, a lot of PDF readers will see that as a harmless change. The other attack they do is the replacement attack. One of the examples of that is you're able to redefine the font. So you can kind of do like a character replacement sort of attack. I thought that one was kind of interesting that you could replace the font, because that seems like it seems like a really tedious and difficult place to do the attack, but also a really obvious thing that would that could make a big impact on the visible content. It seems weird that the font is a harmless change to me.
Yeah, I was thinking the same thing.
I could kind of understand it when you have like font classes. So it's like, oh, you don't have this one font. Okay, you can use Arial instead of I don't know,
Times New Roman,
I don't know.
or whatever.
Yeah, whatever. Like you could use, like, I could understand maybe some of the font swapping. But yeah, it kind of follows the same idea. Either you can replace with an overlay or replace with an update. A lot of objects can't actually be overwritten with an incremental, but as I was just mentioning, the fonts can be, and that's actually, I believe, the only one that they talk about that can actually be replaced with an override. Otherwise, it's they'll use like forms will support input masks on text fields or text areas, radio buttons, and I thought this attack was really cool. So you would set your form placeholder value. So this is the same idea with like an HTML form. You set that placeholder value, and then the browser will show that text until you go to enter something. The difference on PDF readers, that text usually looks exactly like normal text. So if you send somebody a document that is, say, pre-filled with all their wiring information, which again, that's the example they use. You have this document pre-filled, but you pre-fill using the placeholder. You can then change with an incremental update after the document's been signed. You can go ahead and change that placeholder value. And because you're not changing the actual value of the text field, only the placeholder that's shown when it's empty, it lets you do it. So I thought that was just a clever way of getting the change in. And then the last attack was a hide and replace, creating kind of a shadow, like entire catalog pretty much. That contains this whole separate document and new content. And once it's been signed, just append the new xref table and trailer that enables all the hidden objects. So there are two variants of that, being either you can change object references straight up from the xref table, or you can change the usage, mention that some are free or in use to get them hidden or shown. So I thought these were really cool attacks again, because they take advantage, they're the harmless things, but they take advantage of something that, well, somebody at some time put some thought into what can we allow, and they found a way to kind of abuse the rules that they created. It's not memory corruption, it's just high level, you thought these rules were okay, but thinking about it more, somebody else, figured out a way around them.
It's one of those types of issues that you are never really going to go away. Those types of high-level logic, design flaw type issues.
Well, as long as you try and allow all these features, is where I think the problem comes in. If you just had the document once it's signed, it is signed. You can layer signatures, but not add signatures. So you could sign a signed document, and that would, like you kind of add a signature on in a sense by encapsulating the entire thing, like signing the entire document. That wouldn't be vulnerable to this sort of situation. It's because of the fact that you can do these incremental updates, and they do it by just updating extras and kind of having this functionality in there and having this whole functionality of updating a PDF, which makes sense for a PDF when you're like filling out a form. You just want to change the value in the form. You don't need to, print a whole new PDF. Like, it kind of makes sense. But when it comes to signatures, I just think that there really should just be nothing allowed. You kind of encapsulate the entire document. Think like a PGP signature.
Yeah, again, it's just the convenience over security aspect that led to these types of attacks. So yeah, there's 3 attack variants, which each have 2 different ways of hitting them. They found 16 of 29 PDF viewers they tested were vulnerable to at least some of these attacks. Among them were Adobe Acrobat Reader and Foxit Reader, which are probably the most popular PDF readers. I've used both in the past. Um, they also introduced 2 of their own tools with the paper, being PDF Attacker to generate these shadow attacks that they mentioned, and PDF Detector to try to prevent them or at least detect them after they've been applied. So yeah, I mean, it's a fun, stealthy set of attacks that could have practical implications. Probably not many. I could think of some, but it'd probably have to be like a malicious corporate environment or something. It'd be like a sophisticated attack. This isn't going to be something that like script kiddies are using to hit people, but it could have practical implications. So
I'm not sure about that. I think in the right scenario, like, this could be used. I guess it is kind of corporate, but I'm thinking of some of the fraud where attackers would compromise a mailbox and then wait for like a wire transfer to be happening and change out their emails, basically, like send some ahead of the actual email. So say your bank sent, or whoever the client is sends like, here's our wiring information, or asking for your wiring information. They'll reply with their own before you get a chance to even see the email asking for it. That's I could imagine, if you're in a scenario where people are using signed PDFs for that, like, this could be. I could see script kiddies kind of using this sort of attack.
that's a fair vector. I hadn't really considered that. So yeah, fair enough.
It's just you
Um,
need to be in the scenario where PDFs are being used like this. Yeah, I don't know. I mean, it's not. I've generally gone with a stronger form of signing over just like that built-in option when it comes to like actually having a digital signature versus like the signature image, I guess you can call it.
yeah,
But I mean, no
you'd
doubt
have to
this is
target a specific
used.
scenario.
Yeah,
Yeah.
like, no doubt this is used in some areas. I haven't really been in that situation.
All right. So we have another PDF-based topic. It's an info leak in Adobe Reader through the ID tag in the PDF trailer. We kind of briefly touched on the trailer, or Z did rather, on the last topic. As I understand it, it's basically a dictionary or a table of cross-references stored as key value pairs. And the trailer contains a few things like the size of the table, the document catalog root, the document information dictionary, and an array of IDs. The problem is, when Adobe Reader encounters an ID key in the file trailer, it'll try to get the size of the ID array values and use that to populate the trailer ID structure. And it uses this function called facro.getFileID to get the actual size of the file ID in the PDF. Even if the buffer is null and the buffer size argument is smaller than the size of the file ID, it still succeeds. So it's possible to get that function to return a value larger than the size of the destination ID buffer. So the ID buffer is always going to be hex 100 bytes in size in the stack object. But by crafting a large string, I believe, you can get it to smash the adjacent length field to get it to return something like hex 400. So when it does that, it'll allocate a really large heap buffer that's larger than the source object, and it'll copy more data than just the source object from the stack. So some of the data it copies will include that sensitive stack data. So the example they give is like hex 100 and hex 400 is what they smash it with. So you would get hex 300 bytes of stack data. So it is just an info leak, but it's still notable because an info leak is a pretty important step of the chain, even though it won't get you all the way to code execution on its own.
Yeah, I mean, it's not
Um,
quite as sexy as having the control flow hijack, but it is just as necessary.
for sure, especially when you're hitting like something like Acrobat Reader. So I will say I do believe like I wish this write up was a little bit better. I think this write up was missing a lot when it came to how the bug worked. There were surface level details, but they didn't go into the relevant function at all outside of its return value and the fact that it could return a value larger than hex 100. They don't really talk about the why, which is a bit disappointing to me. My guess is that it just does something simple like a stir len on the ID, and then if it doesn't reach a null, it'll just keep reading past hex 100.
I mean, they
I'm
very
not sure
well,
on that though.
yeah, they may not have even looked into it. I mean, this is Acrobat Reader. It's not open source. They can't just see what it does. They have to do some reverse engineering for that. So it could just be that they noticed this in testing or in fuzzing and didn't dig into the specifics of what or where that function was determining the length or how it was doing that, just that it did and you can do this. And like it didn't matter if it was using Sterlin or something else. What mattered is the end result.
Which is totally fair. I just wish, like personally, that we got a little bit more information on that, but maybe that's just like, that's just me, I guess. Um, but yeah, they do include the pseudocode of the acro file ID get from doc, just not the get file ID function, which is relevant for the bug. It does look like it would be a little bit tricky to dig into. There is quite a bit of indirection in the pseudocode because it's C++, and reversing C++ binaries isn't particularly fun. It's definitely not something I like to do. But yeah, I mean, as much as I wish we would have got more information. This is kind of a cool bug. These types of info leaks are like an info leak of hex 300 bytes is extremely useful. Um, there's a lot of info leaks you'll see that are like 4 byte or 8 byte leaks, which like really suck to try to exploit. But these types of leaks are extremely useful, and it's a cool bug. So um, we definitely wanted to cover it still. And it contributes to that PDF theme of the episode. So it was perfect timing by ZDI.
And now we'll end that PDF theme.
Yep,
They're just
it's all
two
over.
topics.
So up next, we have a researchy kind of post from Detectify Labs about some common middleware misconfigurations that can lead to web apps being exploited, and what types of strategies can be used to exploit those issues. It's mostly centered around Nginx configurations and HTTP splitting, which we've talked about similar attacks before. Maybe not specifically with HTTP, but it's basically the ability to inject new lines into a response to tamper with the response header. So we've talked about similar issues before. Z, I'll let you take this one away because I know you found this one interesting,
Yeah,
and
so
you're more interested in the desync type attacks, I guess.
well, so this kind of you related this with the HTTP response splitting. And while it's similar, so I guess I'll slow
Response
down here.
smuggling, yeah. Sorry.
Well, I mean, it is similar to splitting, or more similar, I think, to splitting here in this case. But anyway, response splitting, don't see a ton of it anymore. I mean, we've kind of seen with some of the things you can sometimes do with desync attacks, you can kind of get it to do a response or to do a split response. But it's kind of an older attack that haven't seen it a lot. Still see it occasionally. We've actually talked about it a couple times. Spectre was saying, basically, like classic example, you put a new line character in the host, which of course you control as you're sending it, and if the server just kind of echoes the host back to you, then you'll have a new line kind of in the header, so you can basically add your own headers to the response, or just add your own content completely for cross-site scripting. What's interesting about this one is it's taking advantage of reverse proxies. In particular, their example is when certain servers will be set up to serve out of a S3 bucket based on regex matches in the location itself. So they use Nginx here. The same idea could probably be done against other reverse proxies. The simple idea is that you'll have this location directive and then you'll have it match, a few things inside of that location directive. In this case, it's matching like let's go /doc something something, like whatever matches that, and then it takes whatever the match was and just tosses it into like that.html and looks for that inside of the S3 bucket that's provided there. Or you could have a more complicated case where it's maybe matching the folder name that you're looking for plus the file name, and then using that to decide what bucket and what file in that bucket you're going for. Kind of that setup, which definitely exists. It's a pretty common pattern. You won't necessarily notice it if you're only making all the right requests. It's going to be hitting the right files. It just looks like a normal server, but it's actually it's actually serving out from S3. So where the issue comes in is, and we've talked about the regex issues before, what about matching new lines? Well, if it matches a new line, it's then going to echo the new line when it passes it into this proxy pass directive. It will, inject any new line that you've done there, so you can now gain control of the other headers in the request being sent, or other parts of the request in general. So they use this on a number of sites or on a number of bounties actually, to basically get themselves arbitrary content injection by, putting in a new host header so that S3 thinks it's looking in a different bucket, or thinks it should look in a different bucket based on whatever the host is. What I thought was most interesting, though, was they used this to try and hit a Redis Unix socket. So you might have Redis running locally, just have a Unix socket, in temp or something. They use temp/backend.socket as their target. By setting up that Unix, injecting that in there, they were able to basically use this bad regex match to to pass the request out to a Unix sock, which I thought was really cool, because of the fact that it's always going to inject that host name into the socket, into the request that's making on the socket. They weren't able to do a lot with it against Redis, but they were able to at least do a mset, which just kind of takes the one line. So with that, they could set the you could basically set any key in Redis to a controlled value, which is a fairly powerful primitive to have. It would depend on the application for how you would actually exploit that, and would require some of that internal knowledge about the keys. But definitely still a very usable attack. And definitely something to keep an eye on, because these regex that don't consider new lines are insanely common when people just casually write regex. It's like, let's use .star, or do like the character matching and just not some character to match it, and forget about the fact that new lines exist and can be matched and can create a lot of problems. So that's where I found this one interesting, just in how you can abuse some of those new lines.
Yeah, it was cool because I think they detailed like 4 different types of attacks you could use. Like you mentioned the Redis one on the local Unix socket, but they also mention how you can access internal Nginx blocks through the XXL redirect response header, accessing localhost restricted Nginx blocks as well by using a host name with a DNS-A pointer of 127.0.0.1. So yeah, it was cool. That's where it was kind of more of a researchy type post. It wasn't a specific bug, but more of a class of attacks that can happen against some of those common misconfigurations. I like this post because I think it's easy for people not to be aware of or shrug off bad configurations, or they just paste a configuration from somewhere like Stack Overflow without understanding the implications of the rule set. And I think that's one thing they actually highlighted here was they took a misconfiguration from a popular Stack Overflow post, I believe. So it's just one of those attacks that could be lying in wait, where you could be hit by it and you just wouldn't realize it, because pattern matching is so easy to screw up, really, when you're writing rule sets.
I think the other thing is that setting off these reverse proxies, they're usually set up in a somewhat transparent way. Like, you don't know it's there until you start making those bad requests. So you don't necessarily even recognize the attack surface.
Mm-hmm. Yeah, it's almost like a hidden attack surface. So it's pretty cool in that way. And those reverse proxies are they're becoming more and more common. I think they even mentioned that too. It's becoming more common for static content, using Google Cloud Storage or AWS or whatever.
Oh yeah, it's
It's
really common, especially, I mean, well, one, using a reverse proxy like this. I mean, you've got API gateway like now as an actual like cloud service offering because it is so common to do this sort of setup. Really since microservices kind of that boom is really where you also had a lot more with these reverse proxies and a bit more complicated parsing. At least that would be my opinion. Somebody could probably come and point out no, it was actually earlier than that, but that's at least where I started noticing a lot more of the reverse proxy setups. But I mean, obviously, it also has the load balancer aspects. So of course, they were used before that too. Either way, I did like this or this attack. I thought it was an interesting thing to pay attention to in the future.
for sure. Up next, we have another research kind of post that doesn't talk about a new bug necessarily, but rather an older bug that can be used against other targets. It's a post by Synactive, and it touches on an old report and how it can be used to find other issues of the same nature, and where that can be exploited. In this case, VMware. So Z, I'll again let you take this one away.
Yeah, they do a little bit of variant analysis, or what they call variant analysis on here. Basically, they just look for any other code that's using the uh same function in a loop. It's very kind of remedial variant analysis. But I did think the bug was interesting, and we didn't cover it when it was actually called out. And the fact that they found other applications kind of making the same issue is really important. I'll get to why in a moment, but I guess first talk about the actual issue. The issue is in GNUPG Made Easy library, the GPGme. So in that library, there are two functions that are important, at least to this attack, which is the GPGme underscore op underscore verify and the GPGme underscore op underscore verify underscore result. So the first one, the verify, I'll also, I think, bring it up here. Oh, I thought they had it. Either way, basically just performs your basic signature validation or verification, sorry. And then the verify results will actually expose information about all of the signatures that were matched in it and like whether or not they were used to sign it. Like it'll give you all the status information. Like it's a little bit more specific. So the code pattern that they saw is that things would call the verify results kind of in a loop. Just trying to find the example in code here. Yeah, so it would iterate over the signatures that it got and then look if the status failed on any of them. So kind of straightforward code in that sense. The issue is that there are kind of two modes where the signature can come in. And that is either you have kind of like a normal clear text PGP signature, that is you've got the body and you've got the signature together. And the other aspect where it was used in this case with the firmware update software was that you would have a detached signature. So you would receive a body of data that's supposed to be signed, and then you would have the signature separately and then look, okay, is this signature, was that used to sign this? Like, is it valid? So what would happen though is if an attacker controls kind of both the piece of data that goes in as the signature and as the signature or signed text, if you control both of those, if there's a value in the signed text, that's used as a hint by GPGme to say, hey, this is probably a detached signature. So it will basically return a success on the first call, that underscore verify, because that's just checking if it's valid. And then verify results will be a little bit more specific about which signatures that it knows about were used here, whatever. So the issue is that verify results will give you basically a null as its return value in some cases if there was no valid signature. Or, well, it's technically when you get the null, it's a list of 0 signatures. So by just iterating on that, basically by having the null, no signatures match, it never enters this internal iteration, this better check. And so you're in some cases able to get an entire, or you're basically able to wrongly pass the verification routine. So anybody using this should know to check the result for null before trying to iterate on it. And that's kind of where the problem comes in. What they found here was obviously this firmware update didn't do it, but they also found that Photon OS, and which is just kind of like they say here, a minimal Linux container host built by VMware, and that uses TDNF. That is also vulnerable and does this signature comparison in that way. So the vulnerability, I mean, I spent a lot of time just talking about, isn't that interesting. It's basically a misuse of GPG made easy. You should be checking the response for null before you do that, before you do the actual iteration on the output.
Well, to be fair, they do check it for if it's null, but they don't check if there's 0 entries. So that's kind of where they were going for there, because they do check if p result is null. And that's where the confusion comes into play.
They should be checking the p result signatures for null.
Yeah, exactly. And I think that's where like the confusion comes into play for developers, is they think, okay, I checked if the result is null, I should be fine to iterate it then, and that's all the edge cases. But there's kind of that hidden case where you don't think about the fact that there could be a non-null return that just doesn't have any values in it. And that's where they kind of blame the API a little bit. And I kind of agree, because it's not like super intuitive.
No, yeah. Like this is GNU-PG made easy. So first of all, honestly, I never recommend using like GNU-PG or PGP or whatever. There's just so much ancient code around it, so many bad designs in general. I mean, it's there, it has a ton of momentum behind it. In theory, the security's fine. In practice, there have just been so many issues, and technically, I can't put this on GPG. It's the GPG made easy library that just seems to overly complicate this. Like, you shouldn't have that one function that I was kind of struggling to describe that has these two different modes, basically. I mean, it's not really two different modes, but that different use case, basically, where if you give it a null in this case, then the function kind of works like this, whereas if this is null, it does that. That, to me, like if I was writing the code, sounds like separate functions.
It's like the union problem, but with functions.
Yeah, that's a good way to relate. I mean, I haven't looked at the code. Maybe it is just a lot of shared code and it actually does make sense. But in terms of what they're exposing to the user, this feels like a bad design to me.
I'd agree.
I mean, I hate to kind of just judge them harshly on that. Like, I'm sure there's reasons behind it, and they rejected this as a bug in their own platform. It's the developer's responsibility. But I think there's a responsibility on the API, especially when they're trying to be, made easy. Like, that very fact is kind of what gets me on it. If this were just some random API that wasn't trying to make something easier, I feel like I might be a little bit more forgiving on it. To say, okay, developers need to be aware, especially if they documented this. Developers need to be aware, and there is some responsibility on the developers for using it poorly. Like, I definitely think that's there. This is just the case, like, it's been made a little bit more complicated than I think it needs to. And that's showing in the fact that developers are using it incorrectly.
It was made easy to misuse.
Yeah. Which, in fairness, actually is pretty common with a lot of, like, C libraries anyhow.
Yeah. So, as you stated, they did find this issue could be exploited through VMware's TDNF as well. Tiny Dandified Yum, it's kind of a weird name, which is used in Photon OS as the package manager, which the researchers at Synactive do throw a little bit of shade at them for. They have this little paragraph where they're like, what's more unusual is they decide to write it in C for a package manager for a secure OS in 2020. So there's a bit of a fun shade thrown around there too.
I mean,
Now,
that is a weird choice.
yeah, I'd agree. I'm not sure what the thought process was behind that either. Um, Now, the good kind of, I guess, thing is they use a custom verification function that isn't vulnerable to this attack for verifying the package, but they do use the TDNF verify result in their plugin, their repog PGMe plugin, or check plugin, which they use to verify the repository metadata. Um, Now, that plugin is currently optional, and the worst you could do as an attacker against Photon OS with this package manager is a package downgrade attack against a system which already uses it, which again isn't the default. So it could still be useful, but it's unlikely. It's not like you get you can forge an entire package, so it's not as damaging against like Photon OS as it might initially appear. Mostly, though, what they wanted to prove here with this blog post is this kind of issue, because it's that like silly design decision by GPGme. It isn't isolated to one piece of software. It can be hid in other places. At the end of the post, they actually note some other places that they found this on too. They found it in older versions of O package and Mutt as well, which I believe are other package managers. But yeah, it's one of those things where maybe it's not the developers at like the library's fault, but because of this silly decision, it can be spreading between multiple like products, not just one. Which is where I think you do have that increased responsibility put on you when you're writing a library to make sure that things are reasonable in the way that they're interfaced with because of that reason.
Yeah, I mean, ideally, security should be by default, like, secure and same defaults. And I think that includes, designing something where it's hard to use insecurely.
For sure. Yeah, I agree. So we have another white paper and another confusion attack. This one gets into credit card attacks, and it's kind of like a type confusion between Visa and non-Visa cards. So the title of the paper is Bypassing the PIN on non-Visa cards by using them for Visa transactions. And yeah, as the title suggests, it's about causing confusion on the terminal side and getting a Visa and non-Visa card mixed up, which leads to a logical issue where the Visa PIN bypass attack that was previously reported. I think you said it was in the summer, Z?
Yeah, it was reported in the summer, so we didn't cover it. I was actually also reminded of episode 21. We did cover kind of a man in the middle thing, but that was kind of separate. But I was at least reminded if you want to check out other kind of Visa, well, I guess the EVM, I think it is. Yeah, or
Yeah,
sorry, EMV.
EVM contactless protocol.
Yeah, the EMV's transactions. We did talk about another, not necessarily similar, but another EMV attack, at least back on episode 21. Yeah, this one, the actual attack came out during the summer. It only impacted Visa. So Spectre was saying in this case, so actually talking about the Visa attack, it would have, as you're going through the transaction, there's this cardholder verification methods. That's like, do you have to enter a PIN for this, or is it just using the chip, or, what verification needs to be done in order to confirm this individual is like the legitimate cardholder? Well, it turns out that the CVM information, that verification method, isn't actually cryptographically protected. So any man in the middle between the terminal and your card could change all of the CVM information, and as a result, the card transaction qualifiers, which I guess I should mention, kind of the same idea there. I think those are two terms for similar thing. The qualifiers determine what verification method should be used. So it's those qualifiers, sorry, that aren't protected, not the verification method. That's just what it decides on. But those qualifiers can be changed by anybody who's kind of in the middle. And that happened with Visa. On MasterCard, those card transaction qualifiers are cryptographically signed, so you can't actually tamper with them if you're in the middle. Which is then where this attack comes in, where while the CTQs aren't, where they might be cryptographically signed, the way the terminal identifies what kind of EMV kernel to load, or like the set of functions that's going to use for this transaction, is by looking at the card number and looking at the application identifier that's being sent. So a man in the middle can modify those because those values aren't cryptographically signed as they're sent over. So you can end up tricking the terminal into thinking, hey, this is a Visa card, and it'll load up all the Visa functions, even though it's a MasterCard, just by changing a few of those, or by changing the application ID. And so by using a MasterCard, changing it over to make the terminal think it's a Visa, you can then have access to that same Visa vulnerability.
So it seems really interesting to me that at the very least they wouldn't check the card number, because for those that don't know, when you have
the card number,
they said that the pan is not checked for the card brand indicators. So that's where I was going off of for that.
Okay, so I know they mentioned the pan being part of how they determine it.
Yeah, so I think both of them escape verification, which is like weird to me that like they wouldn't use that. For those that don't know like what I was talking about, they're basically different card brands like Visa and MasterCard. They'll have like different like secure numbers, I guess is how you would say it.
So the first numbers of your card indicate like who the issuer is, and then the type of card that you have, and then it's your actual individual account number. So those first numbers, like if you have multiple cards from the same bank that are all like Visa or something, they'll probably have like the same first 4 numbers or so. So that's also used to determine what kernel to actually load.
Yeah, so just to clarify on that point of temporary confusion, on page 6, they say, also note that the EMV does not specify any mechanisms to match up the card's PAN with the advertised AID, application identifier. So
yeah, so it doesn't match those two. I still thought it could use the number, though, to determine the kernel. It just doesn't match that, or it doesn't make sure that the card number matches the application ID, which you're saying, which is where MasterCard's fix for this was part of the authentication data that gets sent, is it sends that AID over as part of actually authenticating the transaction. So you can't just change that to match like some other card like they were doing for this attack.
Oh, I see. Okay, that makes a bit more sense. So yeah, I mean, it's kind of fun that they came up with this new attack to exploit that older attack. In their research, they managed to build a POC through an Android app and used it to bypass the PIN verification on 2 MasterCard credit cards and 2 Maestro debit cards, all from different banks, just to verify that it wasn't like a specific issue that only hit one type of card or something. But yeah, it's essentially using this confusion bug to exploit a known bug on different cards. What that can result in the real world is an attacker using 2 phones to man in the middle and perform a replay attack on the victim. So they use 2 devices because they have a card emulator device near the payment terminal for proxying the replay data, and then the point of sale emulator device near the victim's card. The emulator then modifies the terminal commands and the card responses to perform the attack. So as I understand it, you do need the 2 devices as an attacker to exploit the issue, but that's mostly just to bridge that gap between your target and the payment terminal. And you're using like Wi-Fi as the medium there to bridge basically NFC between the 2 different devices. But
I think it
was a cool attack.
The attack we talked about back on episode 21 was about that. I believe they called it like a wormhole attack, where they would be able to man in the middle of the traffic, and that was back in 2019. So this seems like almost an extension of that. Like now you're able to man in the middle. Now what are we able to do with that man in the middle?
Yeah, it's building on previous research, which is always fun to see.
Yeah, I mean, most papers build on some previous research.
Yeah, but some of the research that like we've covered, and at the time we didn't really know what the practical implications were, and this is kind of like the crescendo, I guess. So yeah, I mean, that got quite a bit of mainstream coverage for obvious reasons. When you start talking about credit cards, the real world impact kind of skyrockets.
Did it actually get a lot of coverage? I feel like this one was actually kind of muted for what you'd expect. Like it didn't pop up on. I don't think it popped up. I'm just gonna look here again. I don't think it popped up on like any of my mainstream news. Okay, no, I do see it here now. Sorry, I had or not. No, I don't. I see this on the Hacker News.
And yeah, I think I saw it on there, and maybe ZDNet as well.
I don't
But
see it over on ZDNet. So like I didn't see this on like the mainstream news that I'd have expected it on. Like I mean the hacker news, okay, they tend to cover some things. I imagine if the Daily Swig hasn't covered it yet, they will. But no, I didn't really see it. And I feel like that could just be because it is Visa and MasterCard. Like they have a lot of sway. They have a lot of influence, so their issues don't tend to get really publicized. Unless it happens socially.
yeah, I think mostly like I saw this on a few of the subreddits that I follow, so that's why I was kind of thinking about that extra coverage. I am surprised though that you didn't find it on um, some of those bigger sites because I guess I kind of assumed that they would be there, like on ZDNet and stuff like that. But if you're saying they're not there, then
I
maybe I was
mean,
thinking
it's
of another
definitely
topic.
possible they could be on with like some title besides what I'm looking for right now. I didn't
Yeah,
think about actually bringing this up as a topic until right now.
yeah, fair enough. But like, regardless, it is one of those attacks that could have the real world impacts. And when you're talking about financials, it does get a little bit more real, I guess, when you're talking about those kinds of attacks. With that out of the way, though, we can move on to Telegram. This was our next article is on Telegram and looking for bugs and its animated stickers feature, which for those who haven't used Telegram, in Telegram you can send these stickers, which are large images or animated images basically, and you can import sticker packs. And these animated stickers are laid out in their own specification called Lottie, which uses JSON as the underlying data format for serialization, which is interesting. I thought it's not totally relevant to the issue, but I would have expected something like this to be serialized in binary. But
Yeah,
that
well,
was
they
just something I
mentioned
was
that
thinking.
too. Thinking that like they would have expected to be like this binary serialized format. I just think it's interesting the fact that you can compile After Effects stuff down to JSON.
Yeah, I thought that was cool. I never knew that. Um, so usually these stickers are part of verified sticker packs. At the time, though, when this researcher was looking into stickers, they didn't verify the data center ID of the stickers, so you could basically forge them, as I understand, by pointing them to your own data center IDs. So these researchers from Shielder wrote their own fuzzer to target rlottie, which is the library for parsing those files. It's a C++ library, and that's from Samsung. Telegram uses their own fork of that library for their applications, which is important because it makes patching the security issues more difficult. Samsung developers don't track security issues because they don't follow under the intended use case or whatever. It's a little bit weird.
Yeah, I mean,
Um,
being exploited, just I don't intend to be exploited, so why would I follow those bugs? But we've
exactly.
seen some of the Samsung code quality with what the QMod stuff, I think it was, where there's like thousands of likely exploitable bugs being found by Project Zero.
Yeah, it's one of those things, I guess, where they're like, if a tree falls in a forest and nobody's there to hear it, did it really fall? If we don't acknowledge security vulnerabilities, maybe they just don't exist. So, yeah, using AFL and libfuzzer, they wrote a harness and fuzzed the library using dumb fuzzing. They even included that awesome comic strip that we've commented on a few times of writing a complex vuln scanner and finding one vuln in 3 days. And good thing I'm not a noob like that guy who used a dumbass fuzzer and found 5 bugs in one day. And the reason they brought that up was they were thinking of going like coverage guided, and then they were just like, screw it, let's just throw it up, and they got a bunch of findings. As you would probably expect with this kind of library, it seems to be like totally unfuzzed. There's no security advisory, so it wasn't really written with that security in mind, or security in the development, like triaging or anything. So they found their most impactful issue that the fuzzer found was a heap out of bounds right in the v gradient cache classes generate gradient color table method. And it was due to a very simple missing bounds check where there was a user provided position and they didn't check it against the table size, which is always a static 1024. This could, on its own, give arbitrary code execution in the 32-bit. In 64-bit, you would need an info leak paired with it, because in 32-bit you could just brute force the ASLR, but you're not going to be able to do that in 64-bit. But towards the tail end of the article, they talk about how they modified that harness to be structure aware and how they considered how this could affect server side code, since animated stickers didn't work in secret chats when they tried to use it. So for those not familiar with Telegram, there's this other feature they support, which is secret chats, where you can, like, with a one-on-one conversation, you can have it like encrypted and stuff. So the fact that they didn't work in secret chat suggested they were doing some kind of filtering on the server side. But the server side code isn't open source. They couldn't really tell, and they didn't really investigate it too much. But what is known is the animated sticker would only get parsed when the chat is opened on the client side. So if you were to like attack somebody with this, the victim would need to open the chat to actually get affected. So it's not really it wouldn't be a 0-click vector, but it's not really a 1-click vector either. It's not like you have to like click a link or something. So I'm gonna go ahead and say it's a half-click vector because I think that makes it sound fun and edgy. So yeah, I'll go with half-click vector.
I'd still consider this just 1-click personally. But...
yeah, I think in the article they call it a 1-click. I just want it to be, on the edge of it.
I mean, well, so I guess it depends. How does Telegram open on mouse down or mouse up? Then it could be half-click. If it's only on the mouse down, then
it is on mouse up. So okay, it is a full click. Fair enough. Unfortunately, though, this attack surface was basically killed. Telegram now makes it so you can only use verified sticker sets. You can't fake them anymore like the researcher did in their POC. They check the data center ID, so it's a bit of a shame because there was probably a lot more fun bugs that would have shaken out of this library, but it was definitely the smart play by Telegram, blocking out this area by forcing the validated stickers only approach. Because it's one of those, like, you'd be playing whack-a-mole with a library like this. It would just be an endless cat and mouse game. So just killing the attack surface makes sense.
And functionally, they only planned to have it. There's no functionality in Telegram for you to send your own stickers. Like, that's not really an intended feature. It's just a lack of actually checking on it. This also, it kind of represents that one thing I talk about a lot is centralized security mechanisms. This way, like, you implement this security check really early on in the application, and suddenly, like, every vulnerability that could be written, like, the developer doesn't even need to worry about it anymore, although they still should, because sometimes things change and attack surface becomes exposed when it previously wasn't. So you should still be aware of security throughout the entire application. But even with that, like, it's now just non-exploitable. Simply because there's this centralized security. So, like, yeah, I think this is a good example of implementing that sort of centralized security mechanisms and really what you should do.
Yeah, it's one of those prime examples of how important it is to mitigate your attack surface. That way you don't have to worry about those crappy issues being used against you or your software. So we'll end it off with a binary-focused research paper, which aims to assess the exploitability of software bugs with a new metric they propose called expected exploitability. So the reason they wanted to propose this metric and write up this paper is they believe the existing metrics for assessing vulnerability exploitability are too inaccurate or limited in scope to be useful on a global scale. So they mention NVD, CVSS, which most of us are familiar with, which we have criticized.
We've bashed it a little bit. Like, CVSS doesn't capture, especially not the exploitability. Like, it does capture some useful information. So at this stage, like, I kind of agree with the authors. That would be nice to have something that actually indicates, like, how likely is this vulnerability to be exploited? Because, I mean, a lot of vulnerabilities might be reported. It's like they're not exploitable, but they're still vulnerabilities. And so, like, I agree with them, but this isn't it.
Yeah, so we'll get to that. This paper is a little bit I think off track, which we'll get to, but like I said, like, we've criticized CVSS ourselves in the past because either they're misassessed or there's just some things, like C said, that don't really get captured well. They also don't account for exploitability over time. That is one thing that they really try to highlight in this paper, is the fact that once a CVSS score is added or something, it's never adjusted for, like, if a POC comes out later that shows it is exploitable or something like that. And along similar lines, they also mentioned the Microsoft Exploitability Index and the Red Hat Severity Rating, which are maybe a bit more accurate, but they're obviously only useful to their respective products. Their scope is pretty limited in what they're useful for. So I believe what they're trying to do with this paper is use machine learning to identify how exploitable an issue is by looking for POCs or write ups of the issue and looking at keywords and doing some statistical analysis.
Yeah, and also social media discussions. The idea being that they will do a time varying view of exploitability, and they're going to train this model based on, as you were saying, data that gets published after the disclosure. And I feel like that's just the wrong place to be doing this. Like, I think this is an important metric. When a vulnerability is first reported, to go and say, like, okay, this is like, it's very likely. I mean, let's not even get too specific. Just, it's very likely that this will be exploited, or it's very unlikely this will be exploited. Like, that's really important to know during those early days for prioritization of patching effectively, or of which ones are you going to invest on micro patching, which are you going to try and detect immediately. Like, it's useful for that. Over time, like after somebody's released the proof of concept for an exploit, do I really care anymore over whether or not that's raised the expected exploitability? Of course it's raised the expected exploitability. Somebody's just detailed basically how to do it. Somebody's going to weaponize that. That's a given when you've got that out there already. Like, it feels like it's only going to update too late.
So I do kind of see that, but I could see how a company would see a vulnerability and think it's not a big deal, and they're like, "Oh, we don't want to deal with the crap that would come with like updating this dependency that we use or something." And then later on, if it's shown that it could be a threat, then they're like, "Okay, fine, we'll update." That said, I don't know how often that actually happens, how often they monitor older bugs for something like that, but
Well, once something starts getting exploited in the wild, then yeah, like they'll usually update. Um, I don't
but
know
just
this.
shown to be exploitable but not being exploited yet is where I wonder if companies would start to care. And on that, like I'm not really sure. It is a fair point to bring up, I think. Where I have more of an issue is I feel like they're looking at the wrong thing because, like, typically when you're looking at a POC, it's doing one of two things. It's either going to be a full exploit, in which case, like you said, you already know it's exploitable and it's going to be weaponized, or it's going to be the bare minimum required to trigger a crash, which is not really going to give you any information on how exploitable it is. So, like, if you were to do analysis like this, I would rather you do it on like a trace or an ASAN report or something that gives you more technical details of what's happening under the hood on the target. Whereas just a POC, like, I don't think it gives you any useful information anyway. Like, it just seems like the wrong thing to target, I guess. And that's where more of my concerns come into play. And that is a good point around the timing. I hadn't really thought about that too much, but like, I just feel like this approach could have went like on a slightly different path and have been much more useful.
Yeah, and I mean, I'm sure this could be kind of useful maybe on the threat intelligence side of things, where somebody might want to, approach this and actually find this valuable to see, okay, what exploits are actively changing like their expected exploitability. But it's just like this doesn't really. I don't feel like this is actually going to tell us whether or not something's likely to be exploited. I, and uh, I feel bad saying that because that's not exactly what I mean, because obviously this does do kind of that, and it is better. Like their results indicate, they did have some higher precision over being able to determine if something was going to be exploited. It's just they're comparing with a lot of things that are based on the like ground truth information about the vulnerability, like the CVSS, which is just vulnerability information coming with that CVSS. Now, I don't think a higher CVSS means anything towards the exploitability, so it's not a good comparison, but like it's not like their research like does nothing. Like there's something here. I'm just not sure if maybe I think maybe a better way that I'd approach this is I'm not sure if I'd say it's expected exploitability. but I'm not sure what else I would refer to it as. I mean, they're looking at the write-ups, they're looking at the proof of concepts, and the social media discussion. Like, social media discussion, I mean, maybe kind of tells you the interest in exploiting it, perhaps. But I feel like that discussion isn't really happening on, like, Facebook or Reddit. So, like,
Yeah,
I don't feel like they actually get the right insight from that. I
targeting it
mean,
more towards threat intel, I think, would make this paper a lot more make a lot more sense than targeting for like security, security researchers or like stuff like that. I think it
I
belongs in threat
can't
intel
say they're
more.
necessarily targeting it towards us versus targeting it towards the threat intel. It's just, it does, if
Well, I
I
think it
feel like it's
was in
just
the
slightly
security
off the ball.
category.
In
Yeah,
terms
what I
of,
meant by that is I think it was in the security like the cryptography and security category on archive. So that's where I was going for. Like, I don't know if there is actually a threat intel category.
there
So
isn't.
okay, so I guess it might have been the best category, but for them to use. But yeah, I mean, like you said, I think this is more useful in the threat intel sphere. I
Like,
did want to touch on something you mentioned, but I'll let you finish your point.
yeah, I was just gonna say, like, there's something here. I don't want to, like, completely dismiss this. It's just when I think about expected exploitability, I don't think it's capturing it, but there is something it's capturing, and I'm not quite sure how I'd phrase that. Maybe I should have spent a bit more time thinking about that before we started recording, but I don't know, because there's room for machine learning here. It's just, and actually, that is another thing. Somebody needs to be constantly running this and constantly updating the in order for this to actually be useful. So this is more like a service that I could imagine being offered rather than an actual um metric that can be used. Also, because it's not a static metric, it's really hard to compare it between things because it might change tomorrow.
Yeah, that's an important point. Is you don't really want metrics changing down the line when you're trying to do comparisons. Um, Now, the one point I wanted to touch on that you brought up briefly was their increased precision. They claim they collected a data set of 103,137 vulnerabilities and got an increased precision from 49% to 86% over existing state of the art classifiers, being the exploit prediction scoring system and the social media classifier. Stating that it's also faster to publicize what's exploitable than something like CVSS, for example. Now, I'll be totally honest. I don't really understand what that means. Um, Precision of how exploitable it is like their evaluation section and results seem a little bit weak to me. And
With
when
their
you're
whole
talking about
experiment
103
with, like, the cyber warfare simulation,
war game, yeah,
yeah, like I said,
there's some buzzwords in there that I don't really know how they piece together. I guess.
okay, like, I feel like there's something to this paper. I'm really struggling to pull out exactly what it is because I don't think it's really expected exploitability like they targeted on. I feel like there's something else to this that might be achieved.
I think you're trying to be too good of a person. I will say personally, I think this is looking at like the wrong thing, and that's not bad. Like
Still
it
research to see
you
how it
won't.
applies, you know. Still,
Yeah, I mean, you won't really know how useful a path is until you check it out, right? So I'm not saying it's like useless research, but um, I just don't think this is really going to go anywhere past this point of knowing that this just isn't really the best path. Like I said, I think if I was to take something away from this paper and put it like look at something kind of similar, I would want to run the POCs and I would want to get a crash report from a SAN or something and look at those. Because when you start looking at, okay, what type of memory am I hitting? What functions are being called by the target? What's the bug class? You start getting a lot more useful information when you're talking about exploitability. And I
yeah, and
think that's the good direction to move to.
I think that's like a better source of information too for figuring that out. But if you take exploitability in the sense of, as we were talking before, the threat intelligence sense, so, you know, is this the exploitability being how likely is this to be exploited in the wild or by an attacker? Basically, that now draws in, I think, some of the source that they are pulling from, it does make it a little bit more accurate when you're comparing it with that versus just, is this a vulnerability that can actually be weaponized? Versus asking the question, is this a vulnerability that is likely to be weaponized? So if you see a spike in social media discussion about this vulnerability, perhaps that's a sign that, yes, it's about to be weaponized. Or, if a proof of concept gets released, it's about to be weaponized. So, I could understand these choices.
Just shifting the result you're looking for, I guess, would make it make more sense. Yeah. Yeah, that's a good point with the threat intel sphere. I hadn't really considered that when I initially read through it. That said, I think we can begin wrapping up the show. We will get to the shout out section. Z, I'll let you go first with your machine learning shout out. Kind of ties back to the last topic a little bit.
Yeah, a little bit. I'm not sure how to say this company's name, but Pia2, I think. They've been doing a few blog posts, actually. This is the third part of security for machine learning. And we used to talk about machine learning stuff quite a bit on the podcast, and, kind of realized that a lot of the attacks end up being the same old thing, just rehashed a little bit and moved on from it. But they've done a nice overview here. Like I said, this is the third one. There's two other parts just looking at some of the different attacks. Like this one is specifically about model skewing. I just want to give them a shout out as a resource to look at if you are thinking about, attacking some machine learning models. You can definitely get some ideas on some of the common attacks that you can perform against some of them. I think the previous one goes with more adversarial data, and then they have more foundational thing for their first one. But it definitely and some good content out of their blog in general. Actually, they published quite a bit of content.
So before we headed out, I just wanted to quickly shout out again that we had the future of exploit development discussion video. Quick self-promotion, I guess. I really like this discussion we did, and we do kind of overlap out of some of the stuff we talk about on the podcast. Like we have some rehashed thoughts in here as well. But I think the way we expand on it is something that we didn't really go into too much in the podcast, and there's some cool insights in there. So definitely check that out.
It's something we've been asked about a lot, or at least I have. Like the questions come up quite a few times, so I enjoyed doing this discussion. It is like if you're going to invest the time in binary exploitation, it's a lot of time to get into it, and is it really worth the effort? What's going to happen in the future? So we do share our thoughts on where we think exploit development's going to go. We are somewhat pessimistic about it. And I will.
But that's just us by nature. I think we're both cynical people.
Yeah, at times. I do. Binary exploitation will be around, but in the future, it might not be as prevalent compared to other areas of security.
Yeah.
Now I've spoiled the whole thing.
Yeah, but if you want more of the nuances and the fun discussion around that, then you can go check out the video.
Yeah, no, I think it was a good discussion.
Yeah. With that said, though, that's all the topics of the day. Thank you to everyone who tuned in. You can catch the VODs on Twitch or on other platforms like YouTube, Spotify, Apple Podcasts, and more 24 hours after the podcast when it's usually live. But this week it will be going up at the same time on Tuesdays, usually at 6 p.m. Eastern, 3 p.m. Pacific. Follow us on Twitter. Check out our Discord for notifications. It's also worth noting that Z set up a feed in our Discord for where he pulls some of the topics for our podcast, so that might be interesting to some of you. I think he set that up at the end of last week. So
yeah, it's a filter of what I feel are some of the more interesting feeds that I'm following. I didn't want to, publish out everything because obviously I get hundreds of things coming through at once. But I did try and filter out to all of the good research that I have, and on a few of the sources, there are places that don't have RSS feeds, so you won't necessarily find them too easily unless you're looking, and obviously a lot of them are actual RSS feeds. And actually some of the topics that we talked about today came up on that feed first.
Yeah, just a nice combination of topics that might be interesting to some of you. With that said, though, we'll be back next week live with the Day Zero podcast again at 3 p.m. Eastern, 12 p.m. Pacific, and we will see you all then.